Basically, it was all last week, leading up to it. I just closed the door on you. I'm sorry.
I thought you had it open. I'm like, all right, I won't have to open the door or nothing. Sandy Justin. He's getting out of the seat already. And then I need all
You guys played home run derby last week, bro?
He was winning.
So let's talk about what's called trig forms, complex numbers. Now this is going to be new. I know that you guys haven't done or worked with the imaginary axis. Last year, when we did work with imaginary numbers, we skipped the portion on how to plot them. Now we start bringing it back because we can do a little bit with it as far as trig is concerned and all. It's actually pretty simple to work with as far as the setups. So what we're going to look at here is real numbers, what are called a complex plane. Now, excuse me, this is basically going to wind up being where we have the real axis, if you will, and then your imaginary axis. And when you go to plot these things out, it's a matter of going, if you have it written out, some value z is a plus bi. Your a values go left and right for real. Your b values go up and down because they're imaginary. Even though there's an I in it, you still count. For example, if I want to plot, I'm going to plot 3 plus I. The a value here is 3, because it doesn't have imaginary 3. The b value is 1. 1 times I. So they move it over to the right 3 and up 1 for the I value. That's how it looks. All right. You remember, your imaginary axis is vertical. Your real axis goes left and right. It's horizontal. So if I'm going to look at negative 3 plus 2i, I go left 3 and up 2. Okay? Left 3 and up 2. What's that? And then, boom! It didn't work. Oh, scared her?
No, like,
Yeah.
I was distracted.
By the who? If I go 2 minus 4i, which way do I go first?
Right.
I go right 2,
Oh, wait, 2. And then down.
and then I go down 4.
So are these just what before I was
Then you would still, if it was negative 4i plus 2, the correct form to write it would be 2 minus 4i. This is the correct form where that always comes first and the I value is second. Now, if it was just negative 4i, what would that be?
0.
Good, very good.
Why?
Because what's your value of a? It'd be 0, because there's no a value. So this would be plotted right here. Does that make sense? So this is totally new. You've never done that. But just remember, real numbers go left and right. Imaginary numbers go up and down. Okay. So now that old joke that we did last year, I can graph it. I'm just thinking about it. It can be. It can be. The three-dimensional planes are
Numbers are represented in line, but now the numbers are represented in points.
yeah, you can do it. Three-dimensional plane comes out this way, where you have your x, y, and z, where you come over, down, and then float it some way or another, come up here. I forget. It's been a long time since we used to plot three-dimensional in Algebra 2, geez, about 4 years ago, maybe 4 or 5 years ago. That's how long it was since we stopped doing it, because it's all CAD stuff nowadays. There's no reason to do it on a two-dimensional plane when you can put a computer and it'll plot it for you. It's just another way of doing it. And plus, every single textbook does it differently, where they might have X and Y going vertical, left, right, Z going this way. Or then sometimes they rotate it where Z is like the diagonal, and yeah, they switch them around on it. So it's not something we do a lot of anymore. Excuse me. So let's try this again. If I want to graph this up a little bit, if I want to graph 5 minus 2i, where do I go first?
Right 5.
Right 5
Down
and then
5.
down 2. Good. Right 5, down 2. If I want to plot negative 2 plus 3i, which way do you go first? Left 2, up 3. What's that?
I hope it's like this on the quiz.
Well, there's going to be other parts to this. What we're going to do.
Yeah, I guess not.
Well, it's just, there's some simple formulas that we use out of it. Once we learn how to plot it, then we can find the distance, and then we can turn it into a trig problem. Negative 5i.
Down 5.
0 and then down 5.
Very good. 4.
Right 4.
Not,
Plain old 4 that way.
not so scary then right away, right?
Not right away.
Right away. I know. I'm trying to take it really slow into this stuff. Baby steps. Very large baby steps.
We're taking the chance. Oh man. Now we gotta
Really low, which is
Didn't you already have the plain ones?
I did. I'm
You
very.
guys must be like from
No, it was
Kids are not.
the
Sorry,
No,
your kids are repulsive.
our youngest got sick towards the end of last week, and we were in a hotel, and it kind of just got passed around a little bit.
Did you go somewhere?
We just went down to Bloomington for the night to see grandparents,
Oh.
but a lot of it has to deal with being outside when the weather's warm, and with all that wind, with all the dust that gets in the air, and it
It's so windy.
was just with all the particulates just got to seep in.
It was so nice one days and then I got
So what we wind up doing here is we need to figure out how to find the absolute value. When we work with the absolute value of a complex number, is basically what we're going to do is, remember, absolute value is the distance, how far something is from 0. And if something is a distance from 0, and you're plotting it on the imaginary axis again, if you plot it where you are real and imaginary, your A values go left and right, your B values will then go up and down. So that's why if you plot it into space here, where this is your point A, B, I, if you will, the distance from here to here winds up being the diagram there. Horizontal change, vertical change. That's how this stuff works out. That's why you get it as the square root of A squared equals B squared. What we're doing here is we're going to take whatever the absolute value is of BI is always going to be the square root of A squared plus B squared. The biggest mistake you're going to make here is you're going to forget to put parentheses around the negative when you square it. Okay? That's going to be the biggest mistake you're going to do. Somebody first ought to do that. So who knows? So if I want to find the absolute value of 12 minus 5i, excuse me. Oops, it's just up a little bit. Well, what's my value of A? And what's B? Good. So it's just a matter of the square root of 12 squared plus negative 5 squared. Good. So you get 144 and 25, which is 169. And the square root of that is 13. So your absolute value here is 13. We do this a lot. You're going to do this little absolute value bit a lot in this section to do other things with it as we go along. Okay. So you're gonna actually get pretty good at it. It's not like it's gonna be horrible. Bless you. Excuse me. Same thing with the next one. Absolute value of -9 plus 3i.
Here, some look like Walter White.
Yeah, he did. It was
Oh.
creepy. You know, I was scared.
Mr. Olin?
Yeah.
Yeah.
I've never seen it.
He usually subs at elementary school. His son and my son are best friends. Yeah, so I know him. So what's -9 squared? 81 and 9 is
90.
90. Now, when we do the square root of 90, you gave me a decimal. Is that going to be correct?
No.
No. What's the square root of 90 simplified?
3 roots 10.
Very good.
Why didn't our calculators do this for us?
I don't know.
See, this is what I done as a sophomore and
Now,
just knew that.
It's not hard. It's just 90. It's just 9 and then.
It's
anyway, do you remember how to use the table? Remember how we did that last year?
Yeah.
You look at your table. If you're going through, you type in 90 divided by x squared, and you graph that. And you look at your table. You're looking at the last value in the y column that's before it goes to all decimals, and that's how it'll work. Also, if you want to simplify that.
Wait, what? So,
Again, if you wanted to plot it and then find the absolute value, I guess I should have given you the answer. So let's plot it and then find the absolute value. Okay, so if we're going to plot -2 plus 5i. Well, first thing I do is draw your axis. -2 and 5i. It's right there. The absolute value then is going to be the distance from that point to the origin. A squared, b squared. Square root of 20. We okay with that?
Yes.
-2 squared is 4. 5 squared is 25. 4 and 25 is 20. And can you simplify that any further?
No.
No. So you would plot it. What's the absolute value? Really?
29.
Well, it's square root. Yeah. Just making
That's
sure.
what I
I know. Just making sure. You guys know what kind of Zoom going on here.
Tuesdays, sorry. People call me on Mondays.
Or you could, you got that like myself. Still be swimming through.
It was better than what we did the last time. Like the last time your eyes were all like.
All right. Same thing with this one. Plot it and find the absolute value.
I knew that.
It gets a little messier tomorrow, but it's a formula, and you're still doing like cosine of 2 pi over bad. Things are going to be easy to bounce around. Excuse me. We are going to go backwards one time after this example.
Right there, you can see the drop.
All right. You get 13 again?
yeah.
Let's take it into the next step then. When you're working with these, sometimes, excuse me, we need to write it in terms of trig. So what happens here is that we can take this complex number and write it in terms of trigonometry. What happens is that you get your plotted point in space like we did earlier. You're able to figure out the angle, which means you'll be able to find reference angles and work yourself through it. Excuse me. So you wind up with a very straightforward formula. As we worry about writing the trig form of a complex number, your A value is going to be, since it's your adjacent, it's the horizontal. That deals with cosine. Your B value is your vertical, therefore it's going to work with sine, just like we did before, x's and y's. So your A value is going to be your radius cosine theta. Your B value is the radius sine theta. Because isn't cosine A over R, sine would be B over R, opposite over hypotenuse, adjacent over hypotenuse. That's where this comes from. So switching it from A plus B I is going to equal R cosine of theta plus R sine theta. Excuse me. And like I said, it looks a lot weirder than it needs to be. Okay. Let me go right into an actual numerical example, because you'll see why you have to use tangent to figure stuff out. Okay. Because to get into my angle value here, to find the actual reference angle itself, that's always going to be B over A, tangent. That reference angle, wherever it winds up being placed, is always going to be a tangent value to find that angle. Okay? So we have to use tangent quite often to get the actual angle to start with. All right? So let's use an example. Oh, we send this out. Oh, did I skip it? Nope. Here it is. So you start with z is -2 minus 2 root 3 times I. A lot of times that I would be outside the radical, before the radical, go write -2I root 3. For some reason we snap this one in on the outside. So we're going to work off of this formula. Doing this out here. We're going to work out of that formula that we know that z, or A, is R cosine theta, B is R sine theta, R is the square root A squared plus B squared. And the tangent of theta to figure out our angle is B over A. Okay. We use that. So the trig form to finish out is going to be z and this is what we're going to put it into. Change this to that. It looks like there's a lot, but it works out real quick. First thing you have to do is find the radius. Your radius is the absolute value. It's that distance from the origin to the point in space. So if I want to find my radius, I know my A value in that form is -2. My B value is -2 root 3. So my radius is going to equal square root, oh, I have too many parentheses here, sorry. -2 squared plus -2 root 3 squared. What's 2 squared? 4. What was 2 root 2? What's that? What happens here a lot of times is, yes, you can go bit by bit. Don't try and put it all in the calculator at once, unless you're dead certain you know how to use all those parentheses, because there's going to be a lot of it going on. One of the things that I would suggest is you're going through these things little chunk at a time, especially with negatives. Disregard the fact that it's negative when you're trying to square it. That way you don't have to worry, especially if you're using your calculator, that way you don't have to worry about parentheses at all. 2 root 3, you square that whole thing, it becomes 4 times 3. 12. So this is the square root of 16, which is 4. So we know our R value is 4. Now, what we have to figure out is theta. The way that we figure out what the theta is going to wind up being is that we know, since we know B and A, that's why we use tangent. Because if you look at this in terms of being plotted somewhere, it was what, -2 and -2 root 3? So that's what, 2 root 3 squared root of 12, so it's a little bit more than 3. What we're doing here is we're trying to figure out the reference angle. Everybody agreed that this point is in the 3rd quadrant, if you will, and if you think of it in terms of regular space. Right? Because it's negative and negative.
Oh, yeah.
So when I do this, I'm getting this reference angle here. That's why we use tangent, because we know the B value, we know the A value. Okay? That's why we use tangents. So basically, you're going to ask yourself then, to figure out theta, what angle has a tangent of, what was it? B was -2 root 3 over -2. What angle has a tangent of the square root of 3? Okay, so it's asking you what angle has a tangent now of root 3. Root 3s are 30, 60, 90. So it's got to be tangent opposite over adjacent. So it's got to be the 60 degrees. What's 60 degrees in terms of pi? Pi over 3, good. Now, this is being plotted in that 3rd quadrant. So what's that angle going to be in terms of pi over 3? What is it?
4 pi.
Good. In order for that to be into the 3rd quadrant, it's off pi, another pi over 3, so this value's got to be 4 pi over 3. So that means that this theta value here is going to equal 4 pi over 3. The reason that it's got to be 4 pi over 3 is because when you plot it, tangent's going to be positive in either the 1st or the 3rd. We're looking at it being plotted in that 3rd quadrant. Okay? So, excuse me, I now know theta, and I now know R, so I'm done. My answer is going to be 4 cosine 4 pi over 3 plus I sine 4 pi over 3. It seems, yeah, this is it in trig form. It's that complex number written in trig form. What we're doing is you know how you guys were like, oh, do we have to do each one of those parts separately? Well, we kind of did. We found the absolute value, that R value, which you guys all said was pretty darn simple. Then we plotted it, which you also agreed was pretty darn simple. So then it was just a matter of getting that reference angle via tangent, because we know B and A.
Do you want us to
Yes, please.
Wait, where is the
Because it was an imaginary to begin with. The final answer is going to have that I sign. So, did I have that on this one? Oops.
Oh, I missed
That's the trig form or polar coordinate, if you will. I think there's even a mode on your graphing calculator for polar coordinates. So yeah, there's a bunch of little steps. But like you guys said, absolute value, piece of cake. Plotting, piece of cake. Finding the tangent value given the opposite and adjacent, working out of a special triangle, should be pretty simple. We've done that a lot. And it's just a matter of putting it all back together in that formula. I think I got one more before we get out of here. I'll show you another example. Let's do this. Formula up. Let's try the same setup. So our setup is starting with a complex number, negative 8i. I'm going to write in terms of trig. What's your value of a? 0, good. So we started out. We know that we have we got to find r first. So in this case, it's going to be, r will be square root of 0 squared plus negative 8 squared. So what's your r value? Your radius here is going to be 8. Okay. From there, we're going to go ahead and plot it. Just call it there. You okay with that? Because it's at 0, negative 8. So we know our radius is 8. So it's on a quadrantal. All right? I'm on a quadrantal. What's my angle? There. $270, so what is it in terms of radius? 3 pi over 2. So we're at 3 pi over 2 then. Yep. It's on the imaginary line because the a value was 0. So we plotted it at 0, negative 8. So that means that I'm on that quadrantal. So that means I'm on a 3 pi over 2. Okay. So then you have excuse me. Oh, and going out of that. I don't know if I'm going to go too many of these. It's starting to fade.
Wait, that's all we do.
No, there's still more to do. I don't know if I want to throw the quadrantals at you guys yet, because I don't think we have one of those yet today. It's on the sheet. Yeah, I don't think I gave you anything on the quadrantals to start with. You'll just do your sheet. That's the first. Yeah. Oh. So then, we still know that our theta value is going to be at 3 pi over 2. So if you continue on from that, our r was 8, our a value was 0, so now it's just a matter of substituting in. So it's going to be, final answer is just going to be 8 cosine 3 pi over 2 plus I sine 3 pi over 2. When it's on that quadrant, what's the angle there? 3 pi over 2. That's all. That's all it was. Because you can say what angle has a tangent value of, it's going to be imaginary. I'm sorry, magic, it's gonna be undefined because it's gonna be, 8, -8 over 0. So where does that work at? Well, it's gonna work at the quadrant, but since it was plotted down at the lower, on the quadrantal on the downward, that's why it's 3 pi over 2, not pi over 2. Does that make sense? I don't think we have time to do the backwards version of that. So I know that there are problems where you are writing it backwards, like 35 and 40. We will start with those tomorrow. So I think it has you doing what, 5 through 40 multiples of 5? So basically you're gonna go 5 through 30 multiples of 5.
Who wrote all this?
Because we haven't done the work backwards yet. So we'll start with that. Okay. Yeah, just go through, it's only this, we'll just do 5, 10, 15, 20, 6 of them. Then we can start multiplying and drawing, start that tomorrow.
No, that's fine.
Okay.
That's 35.
I wanted to get a little further, but not the other way.
It could be.